Here is a question that breaks ordinary algebra. 2 to the power x equals 10, solve for x. The unknown is trapped up in the exponent, and no amount of dividing or square rooting will free it. You need a tool built specifically to reach up there and pull the power down. That tool is the logarithm. In this unit, you meet the exponential function and its mirror image, the logarithm. You learn the 3 log laws that turn multiplication into addition. You crack equations with the unknown in the power. And you tame the special number e, the one rate of growth nature actually uses. 2 functions undoing each other forever. A logarithm simply asks a question. What power do I raise the base to get this number? So log base 2 of 8 is 3, because 2 cubed is 8. Read that sentence both ways and you have the master rule. A log equation and a power equation are the same fact, written from opposite ends. Because they undo each other, their graphs are mirror images in the line y equals x. The exponential rockets upward, never touching 0 from above. The logarithm is that same curve tipped on its side, creeping rightward, never touching its vertical wall. Each one's domain is the other one's range. A perfect reflection. Now the engine of the whole unit, 3 laws that demote arithmetic by 1 level. A log of a product becomes a sum of logs. A log of a quotient becomes a difference. And a log of a power pulls that power straight down to the front as a multiplier, which, finally, is how we free our trapped exponent. Watch the power law rescue our hook. Take logs of both sides of 2 to the x equals 10. The power law drags the x down to the front, and suddenly x equals log 10 over log 2, a number your calculator hands over instantly. The exponent has been pulled down to earth, exactly as promised. Among all possible bases, one is special. The number e, roughly 2.718. Its curve, e to the x, has a magical property. At every single point, its height equals its own gradient. The function is its own derivative. That is why e shows up wherever growth feeds on itself. Money, populations, radioactive decay. The logarithm to base e gets its own name, the natural log, written ln. It is the inverse that pairs with e to the x, so ln of e to the x is just x, and e to the ln x is just x. Each scrubs the other out completely. Whenever the base is e, reach for ln, and the two collapse to nothing. The exam loves 2 shapes. First, the unknown in the power, e to the 2x equals 7. Take ln of both sides, the ln and e vanish, leaving 2x equals ln 7, then just divide. The golden rule whenever x hides in an exponent, take logs immediately and watch it fall out. Second shape, the unknown trapped inside a log. Here you do the opposite, raise the base to undo it. But one warning that examiners adore: a log only accepts positive inputs, so always check your answer doesn't ask for the log of a negative or 0. Find a solution, then make sure it is actually allowed. One last power move. Suppose data follows y equals a times x to the n, with a and n unknown. Take logs of everything and the power law turns it into log y equals n log x plus log a, the equation of a straight line. Plot log y against log x, and a messy curve becomes a tidy line you can read. The gradient of that line is the hidden power n, and where it crosses the axis gives you log a. So logs do not just solve equations, they straighten curves into lines, and lines give up their secrets without a fight. That is why every data question in disguise begins with the same instinct: take logs. Here is the entire unit as one poster. The big picture. The exponential and the logarithm are a mirror pair, reflected in y equals x, each undoing the other. E to the x is the special self-growing curve, and ln is its partner. Memorize this reflection and half the unit is already yours. The 3 log laws turn times into plus, divide into minus, and a power into a multiplier. To solve, the rule is symmetrical. X in a power take logs, x in a log exponentiate. And whenever the base is e, ln is your scalpel, they cancel cleanly. And the boundary fence so you do not overvise. Differentiating and integrating e to the x and ln x is real and examined, but it lives in the calculus units, not here. For now, this is the whole game: a mirror pair, 3 laws and 1 instinct. When in doubt, take logs.